There are two types of floors in Revit, that being architectural floors and structural floors. To find the floor tool, I'm going to come to the architecture tab and in the build ribbon, come across to where it says floor and click on the little down arrow. So you'll see there's architectural floors here and structural floors, as well as a method to create floors via faces. This is really for conceptual masses. And then if I go to the structure tab, you'll see there is a floor icon as well, a floor command, where if I click on that drop down box, structural floor is first and architectural is second. So you can access them both from either tab, an architectural floor from the structure tab or a structural floor from the architecture tab. A little bit confusing, but it's the same thing. So I'm going to go to my architecture tab and click on the drop down box. And the key difference between structural floors and architectural floors, well, there's a few. So if I click on an architectural floor and I'll just draw a square floor like so, that just appears like that. And you'll see here you've got some dimensions and some other instance-based parameters. If I do the same thing again with a structural floor, even using the same type of floor, so it's just a generic 100mm concrete slab, you'll see when I do that, first thing you'll notice is I get a span, a directional span icon for the structural floor. Secondly, if I click on the floor itself, you'll see that now under the structural component, the structural box is ticked. The analytical model is ticked. And what that is, an analytical model is used for, as the name implies, analytical structural analysis and load paths of structural items inside of your BIM model. It also has the type of rebar, both face, bottom, and other face rebars. And the other component is that you can do some other things with sorts of structural decking and whatnot. To be honest, we're not going to dive too deep into that because it's rarely used by architects, much more so by your structural engineers. You can use structural floors if you wish in future, but for our course we're going to focus on the architectural floors. So when we go up and click on floors again, I'm going to click on architectural, and straight away I'll come to my create floor boundary or modify palette. So I've got all my different methodologies of creating floors. So again, I'm just going to click on the rectangle and just draw up a floor. And so I draw, essentially you sketch the boundary of that floor. If I was to put a circle in the middle or another rectangle over here, or I could then go add another rectangle here, I would have to make sure that it's one continuous boundary. So this won't work. So I need to firstly delete that line of the rectangle and then come up to my trim tool, which is just there, trim extend, or TR for short. And I click once and click twice. The difference with trim in Revit versus trim in AutoCAD is that you click on what you want to keep in Revit, you click on what you want to get rid of in Rhino or AutoCAD. So I click on these two items and that goes like so. And then when I'm happy with the shape that I've got, I then click the green tick to complete the sketch, and that floor is now complete. So if I go back to my 3D view, you'll see there's that slab there in three dimensions with the cutouts included. Now, doing full cutouts like this is rare. You would normally do this using other tools like a shaft tool, but we'll get to that again a little bit later on in the course. This is more so for like commercial buildings more than residential. The other thing you'll notice too is when I click on that floor, you have again a range of instance-based parameters, including the level that floor is associated to and the offset from that level. So I'm going to change that back to 0. That will lift up, but then you can see I can change this to level 1 just by clicking on the drop down box, changing it to level 1, and you'll see that floor will just jump straight up to that level. The other one too is if I wanted to create multitudes of slabs that are the same, I can just hit the click on the slab and go Control C, and then come over to my modify panel and come under paste where I've got a drop down box and say align to selected levels. So I'm just going to do it for all of these levels, but let's say I've got a 50-story building. I could click all 50 stories and it just stacks them on top of each other, one on top. So I've got one for ground, for the ceiling level, level 1, and ceiling level again as an example. The next item is if you take a look at some of the dimensions in terms of the reporting parameters, it's giving us our perimeter space, our perimeter length. our total area and volume, the elevation at the top and elevation at the bottom of the slab. And that elevation is relevant to your reduced level, your RL, plus the thickness of the slab too. So we'll stick with just the generic 100 mil floor at this point. We'll come back and we'll edit the materials and the makeup of that floor shortly. And so the best way to think about floors in Revit, or generally Revit itself, is that there's no trickery here. You build your model the same way you would actually construct this building. So the floor slab will go underneath the entirety of the floor, and then we would then have a reveal for our slab edge, and then pull down our brick veneer wall, and that would sit on the reveal just like it would in real life. We would also model our concrete slab, but then we would have another floor that we'll create later on for our finishes. So we'll have like a 20 millimeter zone for our floor tiles, and a 10 millimeter zone or 20 millimeter zone as well for our carpet layer. And these are separate floors that are drawn on top of the concrete floor. So next up, the way that you would do this is I'm going to go back to floor and go architectural, and it goes into sketch mode, and you can see that I can't select anything at the moment, but I can draw my walls. The method in which I would suggest that you do this is that we want to make sure that we are aligned to the outside face of the timber stud, because remember, the air gap and the brick sits down on a reveal on the slab edge. So what I'm going to do is I'm going to be very careful, and you've got two options. You can either trace along, I'm just clicking and drawing and tracing along the perimeter of the stud wall, or another method that I like to use is I will purposely draw outside the boundary. So I'll do something that looks like this. Notice as well I'm ignoring the garage, and you'll see why shortly. And then I'm going to use the Align tool. This is an incredibly powerful tool in Revit, where you go up to the Modify panel and you click on this button here, which is Align, or the shortcut is AL. And then what we do is we're going to select the face of the timber stud and align this line to that place there. So by default, you'll see in Revit, it picks up that dash line, which is the center line of the wall, or it will pick up the internal face or exterior face by default. The method in which you select the face of the stud is you have to hold your mouse over or near that line that you want to pick, and then hit tab on your keyboard. And when you hit tab, it cycles through the closest items for selection next to your mouse. So I'm going to go click there, and then I'm going to click on the line that I want to get there. And I can click on the lock tool if I want, but I'm not going to do that. If I do click on the lock tool, what that means is if I drag the wall to grow, the floor grows with the wall. So you don't have to keep adjusting the floor relevant to your walls. The reason why I'm not showing you, or the reason why we're not doing it, is because it is kind of a restrictive workflow. You've got to be very sure that that's what you're doing. The other thing too is if you don't keep track of which items are padlocked and which are not, you might be working in a team and you might go move a wall and you'll get like a ton of errors that appear saying items are breaking, they can't join, things will be deleted, views will be stuffed, and it can be a really tricky tool to sort of organize. So I'll be honest, I rarely see it used even in large practice, even on very large buildings, because it's just easier to not have that many warnings and errors that appear. So let's keep going around. I'm going to hit tab on the keyboard. I'll hit tab a few more times till I get to the face of the timber stud. So I'll click that line, and then I click the magenta line to bring the sketch in line with that. I'll keep going around. Oops. Keep going around here. And around the front door as well. And remember, hit tab on your keyboard to get that line to appear. All right, so I'm going to follow the inside face of the garage, and the same with the laundry. I'll go to the inside face of the garage and then to this timber stud just there. So if I toggle my thick lines back on, it looks like this. It becomes much easier to see that that sketch. Okay, the magenta lines is a sketch, and I'll hit OK. And what will happen now is all that line work will be covered because the flooring is, I guess the slab is now sitting over the top of the background image. So if I go to my 3D view, it looks something like this. Okay, And if I sort of orbit underneath, I'm going to change that. That should be sitting at ground level at 0, right on 0. And so when I click on that floor, you'll notice as we orbit sort of underneath the model, we're not covering the entirety of the brick wall. And we'll cover that in a little bit, why that is and how we fix that. Next up, I'm going to finish off the garage by drawing my concrete slab in the garage and then dropping that further down, because it's pretty typical that in garages you have a step down into your garage area. So I'm going to go back to my ground floor plan and let's go for another floor. And let's just draw a rectangle to begin with. And I'm going to do something that looks like this. Okay, but then I just need to clean this up here. So I'm going to use a different tool this time. I'm going to use the Pick Lines tool. This is a great tool to utilize. So under my sketch palette, I'm going to click on this one here with the green line and the arrow. And what this allows me to do is to just pick lines, and it will draw the floor on that line. So I'm going to hit tab on my keyboard, find that inside face of the stud. I'll click there, and then I'll find the inside face of this stud here. Click there. Okay, so if I turn on my thick lines, it looks like this. It's a bit of a mess at the moment. But I'll grab my trim tool, TR for trim, and I'll click once there, and then once there, once there, and once there, and then clean this up here. I want to keep this, and I want to keep this, so it gets rid of that. So it looks something like this. And I'll say OK. And I'll go back to my 3D view, and this is actually correct. Even though the walls are not coming all the way down there at this point, that is correct. So the concrete slab in the garage is 100 millimeters below the concrete slab of the house. So you've got this step up from the garage into the laundry. Okay. All right. So next up, let's just double check the structural makeup of this floor. So I'm going to click on this slab. At the moment, it's a floor generic 100 mil. And if I click on the drop down box, you'll see that there's a bunch of floors that are made here by default. Some with a metal deck, others with beam and block, others with like sandwich panels, all sorts of stuff, insulated concrete. And whatnot, but we're just going to stick with the relatively generic ones. So I'm going to come up to edit type, and let's go into our structure. Okay, and under structure at the moment we just have there is no material assigned, so I'm going to click on the 3 dots and we're just going to find concrete. Okay, and you'll see there's a bunch here by default, so I'm just going to click on the concrete cast in situ. And you'll see that it will turn like a lighter grey, and you'll have a cut pattern of the concrete hatch as well. So okay, and okay again. And you see that updates to show us the concrete hatch and the cut. Okay, and that's now done. So the concrete now appears lighter. And because I use the same type, these two types are the same, they've both updated. One thing we should do is let's go edit type again and rename this. So let's call this one 100 underscore concrete, and that's basically it. That'll be fine. So it's 100 mil and it's a concrete floor. I'm now going to draw our walls on the first floor. So I've gone to our first floor view in the project browser, double clicked on that, and I can't see anything at the moment. The first thing I have to do is adjust the view range so I can see what is beneath the first floor. And to do that, I go into the properties window and come down to where it says view range, and I click on edit. So when I click on edit, this view range dialog box appears, and if I click on this little button here that says show, it brings up a really helpful key and diagram depicting on which one of these elements does what, which in these adjustments here. Going through it briefly, the primary range, what this means is the top view means where we are currently looking, like where our eyes are in a floor plan, looking down. So imagine we're sort of stuck to the ceiling and we're looking down on the floor. We are currently 2.3 meters above the floor level. The cut plane means essentially where the floor plan is cut. So we know typically that floor plans are cut 1 meter above the finished floor. In this instance, it's cut at 1200, and the difference is negligible. It's not that big of a difference, really. But if that was set at 2.3 meters or 2.4 meters, you wouldn't see the doors because you wouldn't be cutting through the doors, as an example. The bottom shows us what we're seeing at the very bottom of our floor plan. And that makes sense. It's generally always to the associated level with an offset of 0. In other words, if there's carpet or tiles on the floor, I want to be able to see that. If that offset was a plus figure, so like say 500 or 600, you wouldn't see anything on the floor because it's sort of like the view depth would stop before we get to that point. Then beneath that, you have this one called view depth, which essentially just means what can we see beyond our current floor plan. And at the moment, it's the associated levels. So it's level 1 and that's basically it. But if we change it to unlimited, watch what happens. So I click OK, click apply, and now we can see what is beneath our floor. We can see our ground floor in like a dashed line. If we change the bottom also to unlimited and click OK, that appears as a solid line. Okay, so the difference between those two, the primary range, it will show us as solid lines, and the view depth will show us in dashed lines. So it depends on which one we want to go with. I'm going to stick with the view depth at the bottom at unlimited and the view depth at unlimited as well. We then want to be able to see our reference floor plans that we were using in the ground floor. So I'm going to go back to my ground floor, click on the reference plans. I'm going to go Control C, go back to level 1, and then go up to my Modify tab, click on that, come across to the paste icon, click on the little drop-down box, and then click on Align to Current View. When I click on that, it does exactly that. It pastes it in the same spot as it was on the ground floor. So again, I'll click on that reference image, and I'm going to go PN on my keyboard to pin that image. So now I can't drag it. Okay. So next up is really pretty easy. We just need to draw our walls, sketching over the top of this, and then drag it and move it on top of our current floors and walls. And really, it's up to you on which walls we want to start with, whether it's the exterior walls or the interior. Again, similar to the ground floor, we're just going to sketch these out and then rationalize them once they're on top of our ground floor, because we need to make sure that there's some alignment between them. So first thing I'm going to do is I'm going to create the exterior walls here, and the exterior walls has got like a different type of cladding on it. So let's go and create another wall type. So I'm going to bring up my walls. I've got wall type 1, 2, and 3. Okay, so I'm going to go, yep. And I'm going to go, we're just going to take wall type 2 and go edit type, and then we're going to duplicate this. So let's go into edit, and then under edit, I'm going to add some more layers. So I'm going to click on where it says number 1 and click on insert. And then what we're going to do is call this a finish. And then this one will be a substrate. So we're working from the exterior side in. So the first layer will be a finish, which will be a timber cladding. The second is a substrate, which is like your timber battens. The third is our timber wall, and then the fourth is plasterboard. Now you'll also have like a membrane layer, but at this point I'm not going to add that because it's very hard to show thickness, or it's very hard to really show anything anyway. We would detail that with a dashed line when we get to our detailed drawings. So I'm going to come up to material and open up the materials palette. So in this instance, we're going to create a new material. So the best way to create a new material is I can either right click in the materials palette and say duplicate, and I can take an existing material and build upon that. The other thing I can do is go down to the very bottom and click on this little ball with a plus icon and say create new material. And when I do that, it will create a default new material. So I'll right click on that and let's rename that. Now the naming of materials varies from firm to firm. Usually it starts with a code or a prefix followed by the description of the material. In our instance, let's get into that habit again, similar to Rhino, where we put a prefix at the start or a code at the start. So we might say timber TL, so TLC, timber cladding perhaps, -01, and then underscore timber cladding. Okay. Then next up, we then look firstly at these 3 tabs. So you have the identity data of the material itself. So we've called it timber cladding. The description, you can type in whatever you want. Again, we could just say, selected timber cladding. The class is generic. I mean, if I click on the drop down box, you'll see there's a bunch of different types here. We'll just stick with generic for now. We can put any comments in there or keywords. Then we can put in manufacturer. So it you could put in the model, the cost per square meter, and then the URL to that website. And then following the last item that I would add in would be the mark. So that would be TLC-01. And so that's the code that's associated to this material. It's up to you how much of this detail you want to fill out. For our assignment, we don't need to fill that much out here. Then the next tab is the graphics component. So firstly, shaded. That's how the object will appear in 3D, or the color that will be given. So if I change this to like a red material, the wall will show as a red color. In our instance, let's change this more to like a beigey sort of brownish sort of color. So I'll just come down to say something like that, perhaps. Yep, something like that. Then underneath that, you've got our surface patterns. So this is the pattern that appears on the face of the object. You have a foreground and a background pattern. Rarely do you use both, I gotta say. Usually it's just one. So the foreground pattern, you then have the option to choose between drafting hatches and model hatches. And this is a key concept that I would write down if I was you regarding fill patterns in Revit. Drafting hatches, you'll notice, are usually much smaller sizes. So when you come down into the drafting hatches and start scrolling through, you'll see 3 mil, 1.5, 3 mil, basically that, maybe 10 mil for a really big one, 3 mil again. And then on the model hatches, you'll see much bigger numbers like 100, 150, 300, 50 mil, 75 mil, 600, even 600 by 1200. The differences between drafting hatches and model hatches is that model hatches are real life sizes, drafting hatches are always stagnant. So what that means is if a drawing is at 1 to 600, 1 to 20, or if the drawing's at 1 to 100, if you're using a drafting hatch, that hatch is always the same size. If it's a 3 mil cross hatch, those lines are always 3 millimeters apart, no matter the scale of the drawing. A model hatch changes depending on the scale. So if we use like a 150 horizontal hatch, those lines are 150 millimeters away in real life. So if the scale of the drawing changes, the distance between those lines actually updates because it's to real life sizes. So generally speaking, a good rule of thumb to use is that your surface patterns are model hatches, and your cut patterns, so when you cut an object and the hatch that it shows you is generally a drafting hatch. That's a good rule of thumb to stick by. So we're going to choose the 150 millimeter horizontal, and I'm going to go OK. And then underneath of that, we can change the color of the hatch itself. So if it appears gray or if it appears black, generally speaking, you want a hatch to be light sort of gray. So I'm going to click on a light gray. And then you have the cut pattern, and then you have got two, again, a foreground and a background for a cut hatch. Right now, I might just leave it as is, and let's just see how this looks. The third tab is appearance, and this is more for rendering. So at the moment, there isn't anything that's been given to the material. You got information regarding that material. You can change the scene, so I might change this to, say, a cube. As an example, I can add an image as my my texture image. So I can go image here, and then it will bring up all my textures, and I can apply them. And this is really relevant for rendering inside of Revit. In my course, we don't go through so much of that. You may go through that in some of your other presentation classes, but that's a whole nother field in general in terms of really material or rendered materials inside of Revit. I find it's rarely used as well. Normally you have your design model, which has all your fancy materials that are used for rendering. Revit is really your documentation tool, predominantly anyway, at least to a certain point. So graphics, that's now complete. I'm going to hit OK. And now we have finish, TLC, timber cladding type 1, and then the name of it as well. And we'll give that just a thickness of, say, like a 10 mil, or probably... might even be a little bit thicker than that. Might be 12, 13 mil. So we'll give it 13 mil. Then you have the substrate, and I'm going to give that 35. And I'll change that to a timber material. So I'm going to go timber. Yep, there we go. So that's like a timber batten, essentially. Then you have the structure of the wall, which is still a 90 mil timber stud, and then you have the plasterboard on the other side, which is 10 mil as well. So that's all good to go. Everything looks right there. So I'll say OK, and then okay, whoops. We need to make sure that we had duplicated that wall. We hadn't duplicated that. That's a big boo-boo right there. So I'm going to go duplicate. Oops. What I will do is I'm actually just going to cancel out. We'll recreate that. So go edit type. Make sure I duplicate the wall first. And let's just change the name. This will be wall type 4 now that we're up to. And then we'll fix the name as well. So we're going to make sure we get the sizing correct. So it's a 13mm timber cladding, TC, followed by a 35mm, which would be a timber batten, TB, or even just you can put in bat for batten, and then followed by a 90mm timber stud, and the 10mm plasterboard, which is still there. Okay. So our total thickness will be 148 for this wall. Okay, that's now done. And now I'll just add this again, so not much to change there. I can do this quickly. So again, just checking our properties before we start drawing the wall. We're going to go with height. The height will be up to level 1 ceiling, at least at the moment. We're going to be drawing this from the finished face exterior. And we're going to change those lines as well. And we are drawing a level 1. So again, I'm just going to eyeball this and start from this corner. And then just draw again in anti-clockwise is generally the best method. Now you'll notice as well that as I'm drawing this, it's showing as a grey line. And that's because we have to update our detail level. So you can see I can be really messy. I could just go like out to here. Whoops. I'm going to draw from like here and then go, whoops, I'm going to draw right here and then go like this, like so. And I can always clean this up too. So I'll go down here and change this to fine mode so we see actual lines. And I can just go trim that up. I can click on a wall and I can just drag it until I'm happy with it. Or I can just dimension it and then clean it up from there as well. So that's our external walls at the moment. That looks fine. And then the next task will be for me to grab my internal walls, so which is wall type 2, and then go around similarly as we did before and draw through all of these. Now, remember where you draw around doors, you essentially draw right over the top of doors because the doors are inserted into a wall. We don't actually draw, we don't make a break in the wall for the door. The door punctures through the wall on its own. So I'm just going to go through quickly and draw up all my internal walls, and then we'll drag this over to our finished floor plan and then rationalize these walls on level 1. With all the walls on level 1 now completed, what I'm going to do is drag these, move these over to sit over the top of our first floor plan. We need to find some reference point that we can conjoin the two levels. Now, this is a little bit different to say how we might design a building in Revit because essentially we've got the floor plans already, those reference floor plans. We've just drawn them both in two different locations and we're going to move them over the top of each other and then sort of connect them. We could have just drawn level 1 straight over the ground floor. And there's absolutely nothing wrong with that. And generally when we're designing buildings, or if we don't have a reference set of floor plans, that is exactly what we're doing, what we would do. Again, the only reason why we drew them off to the right and then we're going to move them across is because we had those floor plans there to reference, so it made sense to continue using them. But nonetheless, you always need some sort of anchor point or reference point between the two levels. And generally speaking, in a larger building, this would be your concrete core, would be your service core and your elevator risers and your elevator shafts, or your fire stairs. Or in a residential house, I would probably start with the stairway as well because they're the non-negotiables. They must line up. So this is our stairway on ground floor, and I'm currently on the level 1 floor plan. This is where we would walk up the stairs, do a U-turn, come around, and then we would come up to the first floor up here. And we can see that here. So you would come up from the ground floor, make a U-turn, come up, and now we're in the lobby of level 1. So let's start with that first. And again, I've eyeballed this, so I'm just going to go, I'm going to select all of these, and we're going to use the move tool. And the one constant I know will be this location just down here. This corner or this corner of the stairway should align. So I'm going to come up to here, and I'm going to turn off my thick lines, and I'm going to go from this point here and drag it across to this point here. Now I can use, if I can only move it in straight lines, and you can see I can't select this snap here, I'm going to use tab on my keyboard, and you'll see the pink square appears and it says endpoint. I click, and now my walls are overlaying each other. And this is why it's so helpful to have that view range turned on, so the view range showing everything below. It's a bit of a mess because it looks like there's a ton of walls going everywhere, but it helps us see what walls are underneath our first floor and what we can actually line up with. So the other thing that we can look at here is that, you know, my stairway perfectly lines up. It's the same width, so that's great. And then the hallway on the ground floor is between here and here, and then my hallway on the first floor is between here and here. It's the same width. So there's some sort of rationalization happening there. The next thing would be is what happens is if you drag your first floor and it looks something like this. So your external walls are overhanging or really far in from the outside of the building. And of course, because we just have that JPEG image, it's not reference, or it's not reliable to absolutely reference from. So we have to rationalize our design a bit here. So what I'm going to do is I'm going to come up to the architecture tab and go all the way to the right hand side, and there's this tool called reference plane, or the shortcut is RP. And what that is it's like a guideline in AutoCAD or in Rhino. So if I just click and then click again, you'll see it shows as a red dashed line, but it's not a three-dimensional object. So if we go into 3D, you can't see that red line anywhere. It doesn't appear, and it only appears in floor plans, and we can turn that off later. So it is an object, but it's just a reference plane. That's what they're called. So what these are really good for is, I'm going to go back to level 1, is I'm going to just delete that, and I'm going to go up to reference plane again, or RP for short, and I'm going to use the offset tool in the green ribbon, or the green bar below the ribbon. I'm going to type in 110, sorry, and say OK. And then what I'm going to do is I'm going to go over the corner of the ground floor brick wall and click once, and then I'm just going to draw from left to right. I'm going to hit spacebar so it flicks the line over. So what I'm doing is I'm actually finding the thickness of the brick wall in that brick veneer wall. And I'm going to do the same thing here, hit spacebar to flick that line over, and I'm just going to keep going till I get to here. And I'm going to do the same thing on the front facade walls as well. So flick that across. That one, these ones I've already lined up, so you can see how those are in the right place. So I know that these external walls, the timber walls, are sitting in the right location. Okay, and then I think, how far did I have this set back here? I think it's 700. That's fine. So set back the wall from the external facade 700 mil on this side. So that looks okay for now. That's all good. And then what I'm going to do is use my align tool. So AL for align. I'll click on the reference plane and then click on the outermost line of my first floor facade. Click that line, and then again here from there to there, and that's now good. So what I will do is then start dimensioning out these walls, and I might making sure that I sort of set everything out from the stairwell beyond there. So the stairwell is sort of like the non-negotiable, and I start setting my walls out from there. And what I can do as well is I might go back into my view range and turn this to my associated level, and the view depth I'll leave as unlimited. And what will happen now is it will dash those bottom walls, so I'll make it much clearer as I'm working away which walls are which walls are on the first floor, which walls are on the second floor. And you can see here's a good example. So the garage wall I've kept pretty rational. So I think this is a walk-in robe. That wall is over the top of the boundary between the garage and the interior of the house. And here's a really good example of the stairway, about how those walls are perfectly lined up. And even again, the hallway on the ground floor versus the hallway on level 1, they're overlaying each other. So it's a good sort of rationalization exercise. The first floor's structural flooring is a 19mm tongue and groove timber floor. So if I select that, I've already drawn it, but I wanted to show you what that looks like. So I'm going to just quickly I'm going to go to my edit boundary. So I've selected that floor and we see here's the boundary. So a few things to keep in mind. Now again, in Revit, we are predominantly sort of drawing this as if we are working out all of its construction details, and this is like a documentation set. So I wouldn't expect to go to this sort of nth degree level of detailing for a design model. But as you head into DD, design development, and then to CD, construction documentation, you would model down to this sort of level. So you'll notice firstly that we've got some cutouts here. So I have modeled a cutout in this riser here and a cutout in this riser here. So there's a linen cupboard here and the bedroom wardrobe here. And the reason why these are cutouts in the floor is because we need some way to transfer services, whether that be ducted heating or pipe work, or water supply, air conditioning. It could be anything, but we need some areas to transfer that through. And I also have an opening around the entirety of the staircase, and that makes sense because we need to be able to get from ground floor through to the first floor. The other thing to keep in mind is that similar to the brick veneer, where we didn't draw the wall all the way to the outside of the brick veneer wall, I've done the same thing with the timber cladding. So the two layers that make up the timber batten and the timber cladding, they are sitting outside of the sketch boundary of our floor. And that's because the timber stud is typically, it will be bolted to or nailed, either or, to the tongue and groove flooring, but the cladding is stuck on the outside of the building afterwards, so it will go beyond that floor level. And to give you a little bit more context, if I go to a 3D view, you'll see how that's done. So I'll just say, okay. Yep, all good. And then come around here, I'll turn off my thick lines, and you'll see that here. So the tongue and groove flooring goes to where the end of the stud is, but this area here where the timber batten is and the cladding sits on the outside of that. And you'll see again, down on the ground floor, we've done the same thing. Our concrete slab sits on the edge of the timber stud. The air gap and the brick will sit lower when we get to that point where we put in the slab edge. Ceilings can be found under the Architecture tab. There's no shortcut for ceilings as they're either a sketch or automatic ceiling based system only. So by firstly going to the ground floor plan, I'm going to go up to ceiling, click on it, and I have two options. I have either an automatic ceiling or a sketch ceiling. So we'll go through both. So sketch ceilings are really powerful as they're just like any other sketch tool. So I can either draw a shape, I can pick lines, I can draw lines however I wish, exactly the same as floors. The only thing to keep in mind is because we're drawing this on the ground floor plan, we need to make sure that in our constraints, in our properties, that we have our level associated correctly. So it's associated to the ground floor and it's offset 2.7 meters off of the ground floor. Because we actually have ceiling levels in this project, we could just say actually it's aligned to a ceiling level and it's 0 from that level. You can do this. You can do that too. Either or is actually fine. Usually, the only reason why it's a good habit, I believe, to do it from the referenced from the ground level is firstly it's easier to understand the height of the ceiling. So you can say that this ceiling's at 2.7, the next one's at 2.5 or 2.4. Sorry, the next one could be at 3.2. The other reason is that in commercial construction, you generally don't have levels for ceiling levels. If we think about the fact that if you were doing a 50-story building, you would have minimum 50 levels, probably more for plant rooms and for mezzanine levels. But then if you were to add a ceiling level for every one of those, you've immediately doubled your levels in Revit to well over 100. Which becomes extremely hard to control and manage. So generally speaking, I'm going to do it this method. I'm going to start on the ground floor and then offset that 2.7 meters. So again, I can just go through and I can trace all of these rooms. Now, it's good practice. It's expected that what we do is we follow around the perimeter of our walls, and this time we're not drawing to the stud but to the face of the plasterboard. So you'll see I'm just clicking and drawing and tracing over the plasterboard. You'll notice as well that when I get to the end of a room, that's one completed sketch. We can see that there. I then continue on, and any room with even wood doors, we haven't put in doors yet, doesn't really matter, you just keep going over that. But if I was to do two sketches, so I do two, I guess what you call them, two boundaries in the same sketch. So let's say I got this area here And I don't know, I'll just roughly just do the garage as well. So I got the garage. So, and then when I'm done with that, I would then click OK, and those ceilings are created. I can't see them in the floor plan because they are above our heads, essentially. So if I go to a 3D view, you'll see those ceilings there. There they are. And all three sketches, or all three boundaries, were a part of the one sketch. So if I wanted to change this and say, actually, I want this to be 2.4 meters above the ground floor, they all move together. But if I want one of them to move, I can't do that. So if I want the garage to be at 2.4, but the interior of the house to be at 2.7, I can't do that because I drew all those boundaries within the one sketch. What I would have to do is, if I want to edit the boundary, I click on the ceiling, and then I click on edit boundary, and I just highlight these and delete those lines in the garage. And I'd go back to my ground floor, and I would go to create another ceiling. I'll sketch this as well, and I'll just go like so. Okay. And then go back to my 3D, and now you'll see that that ceiling in the garage selects separately from the ceilings inside. So if you have a bulkhead or anything like that, keep that in mind, that you would have to do them as separate ceiling objects or ceiling sketches. So this one I could make like 2.4, and the others could be kept at 2.7 as an example. The other thing to note is that we are using a standard compound ceiling. So I'm going to go into edit type, and then go edit. And I'm just you can freeze it right there, and you can see how this is created. So you have a core boundary, which is the substrate. So in this case, it's a metal stud, which is our our ceiling battens, which is 35mm thick, with a 10mm ceiling plasterboard stuck to the underside of that. Sometimes they can be stuck straight to the floor joists, but in this instance, we're going to use ceiling battens first, and they're a metal ceiling batten, 35mm thick. So that's the type of ceiling that we're utilizing. The other method to use ceilings, and this is pretty powerful, at least in this instance where we've got a relatively simple interior. This is not, again, used so much in commercial because the variation and complexities of ceilings in commercial buildings is actually very high. But in residential, this works quite well. I'm going to go back to ceiling. I'm going to stay in my 3D view because this works better. And I'm going to use the automatic ceiling. So when I click on automatic, I still have to make sure I've got my constraints correct. So I've got it's going to be bound to the ground floor, but offset 2.7 meters. It is a room bounding ceiling, and it's going to be using that same compound ceiling we just used. As I hold my mouse over areas in the model, you'll see they highlight red. And what that is showing is the path or the boundary of the ceiling itself. All I have to do is just click, and it will create a ceiling over that area. You can see as I'm going through, it's creating them all. The good thing about this, I mean, that is so easy, but the other good thing about it is it creates them all as individual sketches. So I'm able to say, okay, well, the garage is going to be at 2.7, but the living room area, I'm going to keep these at 2.4 meters for my ceiling height, as an example. All right, so that's one way of doing it. But if I wanted to edit the lounge room, I can do that too. I can go into edit boundary, and I can start like drawing and tracing over this and splitting these two ceilings, because maybe I want the living area to be at 2.7, but then the kitchen area is at 2.4. I'm not sure why, but you do have that option too. Regardless of whether you use the automatic ceiling or whether you sketch the ceiling, you have to make sure that you go around the walls. Very commonly, it's pretty standard practice that someone that sort of learns Revit the first time, some of the courses will just teach you to do something like this. So I'm going to go back to ceiling, sketch ceiling, and I'll just go from here to say here. I'm just being very rough. Something like that. Okay, I'll go back to my ground floor, and it looks something like this. And now that may graphically look right, but the difference is that the ceiling is going across the top of all of the stud walls. Now, from a construction method, that's not true, so that's a lie straight away. But more importantly, it may not seem like a lot, but you're going to get false readings of material and of areas, and that's incredibly important if you want to schedule out the amount of volume or the amount of area of material you want. So let's say that you're a builder and you want to quote how much square meterage of plasterboard you need. You can see here at the moment that area is 86.1 meters squared, but that's not a true representation because you're including everything that's sitting above the studs, and you can see it sort of graphically sort of freaking out because there's two surfaces in the same place. And you may think, okay, well, it's a 90mm timber stud with two 10mm plasterboard at the side, so you're talking 110mm wide. Is it really going to make that much of a difference? Well, it will if you have, like, I don't know, 100, 200 linear meters of that width, you know. So with that in mind, if you had like 100 meters or 90, sorry, if you had like say 90 linear meters of 110mm wide wall, that's actually 9.9 square meters that you are miscalculating, which is a substantial amount. And now, again, think about this across, you know, let's say you had 50 levels of a building. That's now 495 square meters that you've miscalculated. That is thousands of dollars in or out of calculation. So this is why it goes back again to Revit is much more rigorous in the method that you model, needs to reflect the method of construction that's being used. So keep that in mind while modeling your ceilings. So with that done, I would then go up to my first floor and I would do the same thing again. So I'd go through ceilings, and in this instance, my automatic ceilings would work really well because I can just go through and click each of these rooms, and that is fine. Having said that though, they will select all as individual items. So if I go bang, 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 as an example, and then go to my 3D view, just going to drag this up. Okay, so I then have these ceilings here. They all select as individual ceilings again. Now, that may not seem like a big deal, but if I wanted to change the height of the ceilings here, like I wanted to change it in every room from a 2.7 to a 2.6 or a 2.4 meter high ceiling, I would need to go through and click on each one of these individually. Now, that wouldn't matter if all of them were hosted to the ceiling level. And you can do that too, right? So I can click on this and say, well, an example here is instead of this ceiling being at level 1 and then offset 2.7 meters, you can see here, this time I've done it differently. I've said that this is equal to level 1 ceiling height and it's offset at 0. So what that means is if I was to go into an elevation, I was going to one of these elevations, and I change one of these heights from 2.7, which it currently is, and I move this down to 2.6, 2.4, I'm just going 2.4, like that, you'll notice that all those ceilings that were drawn and associated to the ceiling level, like so, they all move with it, relevant. They don't stay in the same place, because if they're, like in this instance, they were, this one here, this ceiling here was drawn relevant to level 1 and then offset upwards 2.7 meters. So there's no right or wrong here. Generally, I would always say you stick with the relative floor level and offset from there, because basically everything in construction is measured from the floor level upwards, not from the ceiling level downwards. But again, in this project, maybe do one way and one the other. Trial using referencing a floor level on the ground floor, and then try referencing the ceiling level on the first floor. Roofs can be found under the Architecture tab as well, and has a drop-down box pertaining to all the different commands or subcategories within the roofing category. So the first option is to create roofs by footprint. That's what we'll be utilizing, and what you do utilize probably 99% of the time. You have the ability to create roofs via extrusion as well, and you can see in the example there that this is pretty good for roofs that have some sort of curvature to it. But having said that, because it's extrusion based, it's really curvature in one direction. It's not like you can loft them or anything like in Rhino. That's really where roof by face would be an example. So as again, the video or the example image shows you there, think of roofs like Southern Cross Station in the city. That is something that would be created via a roof by face. So you could create like a complex geometry inside of Rhino, bring it into Revit as a mass, and then select that mass face and create a roof off of it. But again, we're going to utilize roof by footprint for now. Then underneath of that, we have subcategories of roof elements. So we have soffits, roof soffits, or eave linings, they could otherwise be known as, fascia boards, as well as gutters. So let's start off with roof by footprint. So I'll click on that. And it's going to prompt us to ask us where do we want to draw the roof. So at the moment, is it referenced from the ground floor, from the first floor, from the ceiling level, or whatnot? Right now, I'm just going to go ground floor just for the sake of this explanation. So I'll say OK. And then again, just as always, you have your modify commands, or your modify sketch panel appears. So what we have here is our basic sketch tools. And the first thing I'll show you is just sort of how to draw roofs. So I'm just going to take a rectangle, click and click again. And you'll notice on the sketch, the magenta sketch, you've got these triangular elements here. What they mean is that an angle is assigned to that part of the roof. So you'll see when I click on that, you've got 30 degrees that's associated with that roof component. This one also 30 degrees. Now you can change them holistically just by selecting all of the curves, all the lines, and then changing the slope. So instead of from 30 degrees, we could say 22 degrees for our pitch. Or you could change them individually as well if you want one to be less or more than the others. So let's take a quick look at what this looks like. So I'll say OK. This is just a basic roof that I've created. Yours may look different, but that's because we haven't created the type yet. I'm just going to create a section box around that element, and we can see what that looks like. So it's a standard hip roof. So I'm going to go back to my ground floor, and let's do another one. So I'll go, I'm going to copy this across. I could sketch it or copy it, doesn't matter. I'll double click on the roof to activate the sketch. Okay, now that's the same thing, that same principle applies for ceilings, for floors, for whatever it may be. I can either click on the element and then click on edit footprint or edit boundary, or I can just double click on the element to activate the sketch. This time, with the exact same roof, I'm going to take these two and I'm going to untick. So I'm going to select this curve and this curve here of the boundary and untick this box here that says define roof slopes. So when I do that, this will create a gable roof. So I'll click OK, go back to my 3D view, and you'll see now that that has created a gable roof. Okay, so open at both ends. We can continue to have a bit of a play with that, and I can go double click on that, and I might choose to introduce that angle back, or the slope or the pitch to that side of the roof. So now you're gonna have a gable end on this side, but a hip end on this side. So I'll click OK, and that's what it looks like as an example. You also have the option, so I'll go back, come across to here, double click. We have the ability to make this a skillion roof too. So what I need to do is untick every curve except for one to define the slope. So this side here, I've got a slope, and we should probably make that much less. So I'll make that, say, 3 degrees, and then go OK, and then go back to the 3D view. We have something that looks like this. And note, whichever side you define the slope from is the lower part of the roof, and it slopes upwards from there. So even if I open the sketch from here, the slope is defined from here. So this is the lower part of the roof. If I swap that over and say, for instance, I'm going to define the slope from this end, and it's going to be 3 degrees, and I'll turn this side off by going to, so even if I hit 0, that's not going to work. I need to click on that line and turn off define slopes, and then say OK, and now the skillion roof grows from the other angle. And then the next type of roof we'll try is a hip and valley roof. So I'm going to create a new sketch in general here. So I'm going to go roof by footprint on the ground floor, and I'm going to draw something a bit different. So I'm going to go something that looks like this as an example. And I'm going to select all of the lines and then change the slope to a 22-degree pitch roof, like so. And then we'll go back to our 3D. So first thing to look at is in plan view, I mean, the roof shows perfectly. It calculates all the hip and valley for you. And when we go to our 3D, I'll just extend this section box across. You can see that it creates the hip and valley roof for us with just the use of one sketch. Incredibly powerful tool, very, very powerful. And if we wanted to add like a gable end to this at all, so you commonly see that, so you might not have hip and valley everywhere. You may want one of these to be gable. I can double click on that. I could click on this one, turn off define slopes on that end there, and say okay. And now I have a hip and valley roof everywhere except for this component over here. And if I wanted to have some sort of extension that comes out, I could do that as well, where you do commonly see something like this too. I'll go back to my ground floor. I'm going to create another roof by footprint. And I'll just do something like this. And I'll turn off the slopes there. These two, I'll make sure they're the same. They're 22 degrees. And I'll say okay. And it looks something like that. And what I can do from here, I've got this roof that essentially intersects with this roof, and that's not quite right because they're going through each other. I can go to the modify panel, the modify tab, and in the ribbon, there's this small button here next to where a button says cope. Next to that is a roof join and unjoin. So I'll click on that button, and what I'll do is click on the edge of this roof, this gable roof we just drew, the extra roof. So I click on that, and then I click on this face of the roof that I want to cut it to, and you'll see now that this roof is now splined really nicely, joint to that, and doesn't intersect and go into the inside of the other roof. This also means we get a much more accurate reading of what our area is for a material takeoff, etc. The default roof types in Revit are not really that applicable to our user case. So you'll find that by default, there'll be generic roofs that are like 100 mil, 125 mil thick. Even this one here, which is 400 mil thick, it's not really applicable to what we use roofs for. The general rule of thumb is that a roof is really just the finishing material or any sandwich component made up of it. The roof does not include the structural thickness. They're separate elements. So the roof type that we're utilizing is just a generic small roof, which is only I think it's 30 mil thick, and it's just with a tile finish. So I'll go into edit type, and then to edit the type of a roof is the same process as ceilings or floors. So it's made up of a general assembly that runs from top to bottom, and top would be from the top surface of the roof to the underside of the roof. And as you can see, we've only got one, which is designated as the structure, which is a roof tile. And I'll go into the material, and the material is just a new roof tile with the code RTL, roof tile type 1-1 roof tile, which has just got like a dark gray sort of look to it. And then a foreground pattern, which is a model hatch under the brick texture, or sorry, brick pattern. And that's fine for what we need. And then I've just got a light gray hatch associated to that fill. So I'll say okay, okay, okay. And that's the sort of look that we're going to get. So that is the roof type that we're utilizing in this project. I'm going to start with our level 1 roof. So I'm going to go into our first floor plan. And what I've done to begin with is I've used those reference planes that I alluded to earlier, and I've offset them 450 mil from the outer face of the building. So from the first floor, that is. So you can see here from the edge of the first floor facade to that reference plane is 450 mil. And I've done that the entirety, the entire way around the building. I've got a couple to add here, which I'll do now. So I'll go RP for reference plane. I'll offset that 450 mil and then trace along the outside of my building. And if it's on the opposite side, hit spacebar to flick that over. And then I'll do it once more over here. So that now works. So with that now done, that gives us the guide. And the reason why we've done that is because we need to trace those reference planes to give us our eave overhang. So I'm going to go back up to architecture, roof, and I've already got my roof that we've created. And I'm going to use the pick lines tool this time. So I'm going to use pick lines, and I'm just going to click on those reference planes. So you can see it's pretty rough because they're picking the full length of the reference plane. So it's all a little bit scraggly. There's some overlapping areas in some areas where they don't actually join. So now I'm just going to go around with my trim tool, TR for trim, and click on the components I want to keep. And this is relatively simple because the whole roof structure is just a hip and valley roof, so we don't have to do any other tinkering here. So that's fine. I will select all those sketch lines and change the slope to a 22 degree pitch. and we're going to move the base constraint of this roof up to level, the ceiling level of level 1. Okay, that looks good. And that's basically it. So I'm going to hit OK. And it's going to prompt us, it's going to come up with this dialog box saying, would you like to attach would you like to attach the highlighted walls to the roof? No. And I would say that 99% of the time, it's do not attach. What that is, in fact, I might just show you very quickly. If I just draw a wall here, and I'll draw actually just a couple of more walls. I'll just draw a square, like a rectangle. I'll do something like this, and then I'll go for another roof, and I'll just draw a rectangle like this, and then I'll make these a gable end. Okay, so I'm going to say, I'm going to tick that. It's going to come up with that. That's fine. Oops, I should do one more thing. Make sure this is on the ceiling level. Okay, and it's going to give me that same, no, it didn't give me that same question. That's fine, doesn't matter. So I'm going to go to my 3D view, and there's that gable roof I just drew. Now, if it asks you to attach the walls to the top base of that roof, it's pretty simple. You can do that after the fact. That's why I always say to never accept the automatic attachment of walls to roofs, because it just end up very messy, and then you need to detach your walls from the roof. Can be done, but it's just time consuming. Normally you want to be very particular about which walls you're going to attach to your roof. So if I click on these walls, I'm going to click on this wall here, and I can click in the modify panel, which appears, I've got this button here that says attach top base. So when I click on that, I then click on the roof, and it basically connects this wall to the underside of the roof and adopts the curvature or the angle or whatever the profile of the roof is. Same with the sides. So the sides I can do that too. I can say attach top base, and I'll click this, and that's done the same thing. But what it does is it cuts the wall at an angle. Now, if this is a typical timber stud construction, I would have a truss here. The timber studs would finish at a certain height, and then the truss would sit on top of the top plates. They wouldn't do this and come up to the other side of a roof on an angle. So it's pretty rare that you want to do that. At the two gable ends, that is common. And again, I can just do that automatically by choosing that wall. Now, if I was to, I'll just do this. So I'll say attach top base to all. If you were to say yes and attach all the walls to the underside of the roof, you'll end up with something like this. And then I need to go through manually and de-attach them. So I can select them all and then say de-attach top base, and then click on the roof. And then that brings them back down. But that's much longer, because remember, it would be doing it for all internal walls as well. If you had a cathedral ceiling or something like that, then that's fine. You would do that, but I would be doing that, again, in very limited circumstances, not by default. Okay, so with that now done, we can take a look at our roof for our first floor, and that is perfect. That looks great. Very good. Next up, let's do the roof for our garage. So I've already drawn that, but I just wanted to show you how I've done that. Okay, so that's pretty easy. It's another hip and valley roof. It's just that I've chosen to draw along the facade. In fact, I'll go to my level 1, so this makes more sense. Okay, so here we are on level 1. I have not given, you don't give these two lines here a definition of slope, okay? You don't give those. And in fact, you don't give this one a definition of slope either. In fact, the only sketch, the only lines that are sloped is this one, and this one. Also notice as well that I am, where are we? We are at the very end. We are aligned to the very outside of our brick wall. In fact, what I'll do, I'm just going to hide the gutter for a second, and I'm going to hide the fascia board. Okay. So there's our roof there, and it is aligned to the very outside of our wall. Oh, sorry, our garage walls. In fact, I think it might be slightly overhung. Yes, it is. So you draw, yeah, it's only 19 mil overhanging the double brick wall on the garage, and that's because we need a little bit of room to put our fascia board on there. So that's the sketch for our hip and valley, or really just our hip component of the garage. And you can pause the video there to see which one of those are sloped and which ones do not have a defined slope. Same angle though, 22 degrees. And then the last one is a little bit more tricky, and that is the skillion roof that's on this side of the building. So I'll go back to my 3D, and you can see from here, here's where our front door is. Got a garage here, and then on this side, we've got like this little skillion roof part. Okay, and so what we've got is, I'm going to double click on that, and you're going to see something that's a little bit confusing. You're going to see like just a big rectangle, a big box. All right, and what I've done is I've defined the roof slope, and in this case, it's only a 3-degree roof. Okay, and I've just basically, this is actually a parapet wall, and that's what's really good about this project is we get to try different types of walls. You've got like hip and valley roofs, you've got like roofs, like garage roofs, where some elements have got defined slopes and others, and then you have this one here, which is actually it's very small, but nonetheless it is a parapet wall, and it's a skillion roof, and then we get to use roof openings as well. Okay, so what I've done is, if I go back to my ground floor, you'll see that this is essentially on the inside of our brick wall. See there, it's not overhanging, it's on the inside of the brick wall. And what I've done is I've left a gap of 150 mil between the inside of the brick wall and where the roof starts. And the reason for that, because that's a box gutter. So we need to put a box gutter on the inside of the parapet, rather than on the other roofs, we attach the gutters to the outside of the roof, so the perimeter of that roof. Okay, so that's all that is. In fact, I just want to clean that up because that wasn't right, so I'll do that. There we go. Okay, and then I'll click OK. And then what happens, you'll end up with a roof, essentially, it's going through your building, which is not right. But what I've done is you have a roof opening tool. So what I'll do is I'll get rid of that roof opening, so I'll delete that. And now essentially I've got this roof that's cutting through my building. What I can do, and this is because it's a skillion roof, we need to do this. So what I'm going to do is I'm going to go, we're in the architecture tab. In the ribbon, we have this openings palette. So I'm going to click on, I think vertical is the best one to use here. So I'm going to click on vertical, all right, and then I'm going to click on this roof here. It will prompt me to select the roof. So I click on the roof, and now it gives me the sketch palette. So what I can do is I'm going to use, even in 3D, I'm going to use my pick lines tool. I'm going to click this wall here and this wall there, and then I can click the other side there, and then that side there, and then just trim these together like so. You can do this in floor plan too. I can just model in 3D. It just comes with time. All right, so once that's done, Revit is having a little think. I'll click the green box, and now that's complete. So if I isolate that roof, by the way, the isolate command, you select what you want, and then you type in HI on the keyboard, and that isolates the element. You can see now that roof has an opening there. And you're going to find this with skillion roofs, that they're harder to do complex profiles with. If you have openings or cuts like this, it's generally better to just do one big skillion roof and then use the vertical opening tool in the architecture tab to get those openings in there. But it really just comes with experience what type of roof type to use, depending on the application. With the roof now complete, we can now attach, we can now draw our soffit or our eave lining, our fascia boards, and our gutters as well. So the way this works is you need a roof to start with. You can't create these elements in isolation. They are hosted to roof elements. They're hosted to the roof category, and that's why when you click on the drop down box under roof, that's why soffit, fascia, and gutter appear there. They can't be drawn in isolation. So we'll start with the fascia board. So I'm going to click on fascia board, and what happens is, as normal, it goes to the modify panel, but I can't sketch a fascia board. I can't go drawing it like I could with the profile of the roof itself. It is going to require me to find edges of roofs and then host a fascia board to that. So if you look in the properties window, we are currently using the fascia board just called fascia. That's the only one available. And if we click on edit type, we are currently using a profile, which is called M_fascia flat 19mm by 235. And in fact, you might want to use multiple types of fascia boards. So it's usually a good idea to name them in the family name as well. So you can call this fascia. And you might say fascia 235 by 19 millimeters, like so. It doesn't have a material at the moment, and that is fine. We can apply material whenever we want, but we can choose whatever fascia profile we want. So there's some defaults in here. You can see like 235, or you might choose 140 or 286, or maybe it's a smaller one that's only 89 mil. But you could draw your own and then bring that in. So it's like basically this is almost identical to a sweep. It's just that the sweep profile is drawn in a family environment as a profile family and then loaded into Revit. And then this system essentially sweeps it on the elements that we pick. That's the best translation I can use. So I'll say okay. And then what we're going to do is, you see here, Revit will sort of highlight either the top or the bottom of the roof. So generally speaking, the bottom is better. The top can work. It's fine to do that, and you can do both. So I can click on the top and you can see it puts a fascia there, but if I click on the bottom of the roof here, it drops the fascia down, and what does happen is it doesn't join them together. But generally speaking, in correct construction methodology, the roof overhangs the fascia board. The fascia board does not go, the roof doesn't stop at the fascia. So I'm going to click on the underside of the roof, and you can go around and click these one at a time, and you can see how Revit joins them for us. But the other thing we can do is, if I just come back here, I can hold my mouse close to the bottom, so I make sure I'm picking up the bottom, and then I'm not clicking on anything, and just hit tab once, and then it highlights the chain of lines that make this roof. So I only have to click that once, and what it does, it creates the fascia boards for the entirety of the roof. I can do the same with the garage. So I'll hold my mouse over the bottom, I'll hit my tab button, okay, and it will chain that together. Sorry, let me just do that one more time. Okay, chains those together. And then what we can do is you can edit them after the fact. Now, one thing to keep in mind is it's kind of like a sketch. So because I did both of those at the same time, the bottom fascia and the top fascia, as in like the first floor and the ground floor fascia, happen at the same time. Keep that in mind, because you want to make sure you have independent access or control of them. So I'm going to go roof, fascia. We've got the same fascia board, that doesn't change. And I'm just going to go tab, click, hit escape again, get out of the command, and that's now complete. Let's do that again for our ground floor fascia. And I'll go back here, like so. Hit escape twice. And now I can access the fascia board separately to the first floor fascia board. Now you've got a lot of controls with the fascia board as well. So I can click on that fascia board, and you have vertical profile offset and horizontal offset. Vertical means if I go like plus 150, it lifts the fascia board above the roof. If I go minus 150, it's going to drop it below the roof. Okay, so if I keep that at 0, it's going to be at the bottom or equal to that bottom line. Then you have the horizontal offset. As you can imagine, 150 makes it offset outwards from the roof, and minus, which is what we want, puts it underneath the roof. And that makes sense, right? Because your fascia board does something like this, and then we put our gutter here, so when our water comes off the roof, it goes straight to the gutter, not onto a fascia board, onto a gutter, as an example. And maybe we don't need to be that far back. We only have to offset it, say, minus 20 mil, as an example, just slightly. Or 25, I reckon, actually. Actually, got to take into account the fascia thickness, which is 19 mil. So 19 plus 20, so we'll say 39 mil. Okay, so it's offset 20 mil back. So it'll look something like that. And we can do the same here. In this case, we need to take into account, that's better, because it needs to be basically flush on the face of the brick wall, essentially. This one in the skillion roof in here, because it's a box gutter, we're going to do something a little bit different there. We'll just wait a second on that one. So with this now done, we can place our gutter, and our gutter then hosts as well to the fascia board or to the roof. So I'm going to come back up to roof and then go gutter, and then you'll see as well I have the ability to host that to my that's the box cutter one. Sorry, let me just choose the other one. Okay, and we'll go through in a second how to create these profiles. So I've attached that as well to the roof, when really I want that to be attached to the fascia board or inwards. So again, I take that same horizontal profile, minus 20 mil, and now that sits underneath that roof. So what I'll do just quickly is I'm going to create a section box, just drag that back so we can see it, and I'll change this. So you can see how this appears. So we have our roof coming down, go straight to the gutter, and then the fascia board here underneath of that. Okay, and we can change that vertical offset to, we might say that's minus 20 as well. Just drop that down slightly like so, or not, depends. Okay, so that's how to create our gutter and our roof. I'm going to finish creating this, and then we'll move on to how we actually created this profile in this gutter, and then we'll move on to the skillion roof. Note as well, you don't have to place the gutters on the, you don't have to host them to the roof. You can host them to the fascia. So I'm going to take the fascia board and then click on the gutter and go isolate, so HI. You'll see that the gutter is actually hosted to the fascia board, and I know that because my fascia board has a vertical profile offset of minus 30, so I've dropped it down 30 mil, and then I've dropped it back inwards 39, 35, not 39, 35. And then I've taken the gutter, and when I click on the gutter, you'll see it has no profile vertical or horizontal offset. The reason for that is because it's not hosted to the roof, it's hosted to the top of the fascia board. That is probably a better way to work, because this way, wherever the fascia board goes, so if we ended up changing this to say 150 outwards, it takes the gutter with it. Whether if the gutter was hosted to the roof, then it would stick with the roof, and I'd have to move them independently. Do note though that if I was to double click on the roof and then move this profile out like so, don't attach, because it sort of like works in parent-child form. So the roof is the master, then you have the fascia board, which is hosted to the roof, and then you have the gutter, which is hosted to the fascia. So you move the roof, it moves the fascia. It moves the gutter because the gutter is hosted to the fascia. It's a little bit convoluted and a little bit tricky to get your hand around, but is very, very powerful when you need to make quick design changes. Okay, now in terms of editing these gutter profiles, in the underneath the video description, there's a link to a Lysard page, Lysard Steel, where you can download a quad gutter family, Revit profile family. And when you open that up, it looks something like this. Okay, and so what we're looking at here is this is a family environment for gutters, it's a family environment for profiles. And so what you're seeing here is two reference planes, and this is the insertion point of where the block begins. And so all this is just a 2D drawing. You can see here, it's just a CAD drawing. That's literally all it is. And so this is kind of like saying this is your profile that you're going to sweep. The profile is drawn in a separate file, and then it's loaded into your project. You don't have to do anything. It should already have downloaded like this. That should be fine. And then what we do is we go load into project. But when you go load into project, what you'll do, okay, you'll then click on the gutter, because your gutter will be like a simple one to begin with, just a generic square looking gutter from Revit. You then go to edit type, and then what we do this time is you click on the drop down box, and you're going to see that Lysard gutter there. You see I have two there. I've got a 115 and a 150 quad gutter, and you just click on that and then click OK, and then this gutter will update to that profile, which is like an Australian standard gutter profile and a little bit more aesthetically pleasing with its filleted edges rather than the sort of the rectilinear shape that the Revit one comes with out of the box. So it doesn't really matter, like with the quad gutter or with this gutter profile, I can make it, whatever object or shape I like, and it will sweep it around. So if I made that just like a circular shape and brought that back in, it would just sweep a circular path. If I wanted to make that like an I-beam, it would do the same. It would sweep around that path. It would just be known, it would be known as a gutter, even though the shape wasn't a gutter. And keep that in mind too, is that because, as I alluded to in my fundamentals course or my fundamentals presentation in class 1, any object that we click on, we can see in the properties window underneath the type will be this little item, this little name here, and this tells you what the category of family is that you're clicked on. So this is currently a gutter family. Click on the wall, it will come up with a wall. Click on the roof, it will say it's a roof family. So you can never sort of get confused on what category is what in Revit. All you need to do is just click on it, and it will tell you down here. Even if this said, this could say, I don't know, it could say like Mercedes-Benz or something like that. It wouldn't matter. Revit would still know it as a wall. You can't change that. All right, so with that now done, I'm just going to hide the roof. So HH to temporarily hide. You see I got my ceilings here, and then I've got my soffit. Okay, so soffit I've just drawn around the outside of the building. And this is relatively easy. You can do this either in 3D or you can do it in 2D. If I go back to my floor plan, I'll go to level 1. Okay, while I'm in this view, I can actually draw my soffit from here as well. I go architecture, whoops, I'll go up to architecture, roof, and then soffit. And then by default, there'll be one, I think it will just be called default soffit or something like that. But I've gone edit type, and you guessed it, just like every other type of compound or assembly, you can change its construction. This is very simple. We're just using a structural item, does not have a material at this point. We can add one later, and it's only 6 mil thick. And what that will be, we'll rename it, and it's just called 6 mil cement sheet. Pretty typical sort of eave lining. And then you can see it's sketched just like a floor or like a roof. So what we do here is you need to trace around that area of the eave line. So you've got between the edge of the roof and the face of the building. So you'll end up with something that looks like this. And in fact, if I just get out of here, what I'll do is I'll go back to my 3D view and I'll click on that soffit, and it is important. Now, I could use a ceiling, I could use a roof, it doesn't really matter, because I could do the same thing. I could even use a floor, but it would be incorrect in terms of Revit's metadata and the way that it organizes geometry. We have a roof soffit category because it's critical for coordination and for data structures later on down the track. So if I click on edit boundary, you'll see how that looks. But one thing you will notice is that if I was to just draw it out to be 450 thick, it won't work because I need it to be on the inside face of my fascia board. Notice my fascia board there. So it's even to the it's aligned to the inside face of my fascia board, and of course my fascia board is offset 35 mil horizontally back into the building. So you need to make sure that that's aligned. Now, if that wasn't the case, it's easy to fix. What I can do is I'll just drag this. Let's say it was out here somewhere. I can just, with my roof hidden in 3D, when I hide my roof, my fascia and my gutter stays on. I can just use my align tool, hold my mouse over this fascia board face here, click, and then click that magenta line, and that will align that sketch to the inside face. I'll click OK, and that's now done. Now, the soffit only really needs to be done on the level 1 roof. Because we don't have an eave on our garage, there's no need for it. We just have a fascia and a gutter. And we're going to take a look now at our skillion roof, or our box gutter roof area, and our parapet walls. For the ground floor roofs, quickly just notice that both of them are hosted to level 1. Nothing above or below, no offset from that level. They're just hosted on level 1. And for our box gutter, we're going to make our own profile. So what I'm going to do is I'm going to come up to File, I'm going to say New, and I'm going to click on Family. And when you do that, it's going to open all the different templates for your family types, or your family categories, I should say. I'm going to come down to where it says Metric Profile. Now, there's tons of different types of profiles. You have hosted profiles, mullions, rails, reveals, steer, nosings, supports, terminations. There's tons. I'm just going to select Metric Profile and then click OK. And essentially what this is going to do is basically open up what is kind of like Revit's block editor, but it's called the Family Editor environment. And so what I've done is it's just a 2D view. There's nothing three-dimensional about this. I'm going to come up to where it says Line here, and I can just draw whatever profile I want. And in fact, I've done that already. So in this version here, I'm just going to close this off. I've drawn, here's our lines. It doesn't matter whether yours are green or red. And I've just drawn a box gutter. And this box gutter is 150 millimeters wide, like so. And it is, I think, 75 millimeters deep, like so. Okay, and it's 2 mil thick. And that's important to note, is it is a closed curve. So if I just select those curves and isolate them, there is a thickness given to it, even if it is only 2 millimeters. There must be a thickness given to it. What I've then done is gone to File and Save As, and then saved it as a family. You can see I can't save it as a project because we are in the family environment. So when I save as a family, I then save it in a relative relative folder, and I start with the prefix PR_gutter. So the reason why I've done that is PR is short for profile family. So I know inside a file explorer, if I see PR, I know it's a profile family. If it says DR, I know it's a door family. Or WIN, I know it's a window family, because in File Explorer, you could have hundreds or thousands of families, but not know actually what is what. And then _gutter, so it's a profile, but it's a gutter profile, not a stair nosing profile, not a railing profile, and then followed by its size. And then say OK, hit save, and then what I'll do is from here, I'll click on Load into Project. So when I click on Load into Project, it will ask me which project I want. You'll only have the one. And then what will happen is I'll then come to my 3D view, is I'll go to my gutter, and at this point you've probably only got the one type of gutter, which is that the quad gutter we worked on before. You'll click on that and go Edit Type, and then you'll duplicate it. And when you duplicate it, you'll call it 150 millimeter box gutter. So it's duplicated, and then under the profile, you click on the little drop down box, and you're going to see your profile there, PR_gutter 150 by 75. So you'll click on that and then click OK, and you'll see that your gutter will have updated. And then because there is no fascia, we have just hosted, in fact, I'll just delete that and I'll isolate the roof. Okay. You're just going to host the gutter straight to the roof. So I'm going to go roof, gutter, click my box gutter, 150 mil box gutter, and click the underside of the roof like so. And then I'm just going to vertically offset this 15 millimeters, 15 millimeters inwards, and -5 down like so. Okay, and that's our box gutter created in our parapet wall, and that's fine. Now again, I'll show you that we could have done anything. So I could go back to this profile, not that one. I'll go to the one we created. So this one here. If you wanted to change the width of that, you could do that. But ultimately, like I can create, something else. So let's say I put in a circle, and I'm just going to make a circle right there, something like that, and then like another one like that. I can say load into project, and I'll load it into the current project. And because I'm editing one that's already there, it will ask me would I like to override it, and I would say yes, I would. And then I'll go back to my 3D, and you'll see there's that profile there with the circles that I just added. Now, I could add any shape I want. So again, I don't actually have to draw a gutter. Revit will just extrude, or it will just sweep whatever shape I have there, whatever profile I have. But in this case, we just are drawing the box gutter profile. Before our next class, you need to be up to date, completing everything covered in the previous 2 workshops. And your building should look something like what's currently on screen now. That includes having modeled the ground floor slab, the first floor exterior and interior walls, the level 1 structural floor, ceilings on both the ground and the first floor, the roof for the first floor, hip and valley, the roof for the garage, and the skillion roof within the parapet wall on the ground floor, including all subcategories like the fascias, the gutters, with the 2 custom types that were created, which is both the quad and the box gutters, as well as the soffit lining on level 1. All these elements are to be modeled correctly and accurately, using the right types and assemblies as demonstrated, with thoughtful care taken around construction junctions and joins.